sir.
Okay.
Good afternoon, sir.
Good afternoon. Good afternoon.
Sir, should we start?
Yeah, just one minute. Let me open my presentation.
Yes, yes, yes. Actually, Tade madam.
Yes, sir.
तुमचं PPT share आहे का सध्या?
No, sir. I have stopped
okay.
my sharing.
Stop,
We will
okay.
just check with the co-creators presentation.
Okay,
first.
okay, okay.
Okay, so shall I share my presentation then?
Yes, 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 sir.
Okay.
Co-creator, sir.
Yeah.
So with your due respect, actually, I would like to share one flyer. So will it be okay for 1 minute if I'll share my flyer
Yeah, yeah.
and then?
So shall I stop this one?
Yes, yes, sir.
Yes, sir. Yes.
Okay. Okay. Just okay. Please.
So is my screen visible?
Yes, yes.
Okay. A very good afternoon to one and all present over here. I, Ms. Payal Tade, Assistant Professor from E&TC Department, on the behalf of AISSMS COE, welcome all of you in 1 week online faculty development program on recent trends in machine learning under the aegis of IET Students Forum ISF and Professional Activity Center of IET. Science knows no country because knowledge belongs to humanity and it is the torch which illuminates the world. Science is the highest personification of the nation because that nation will remain the first which carries the furthest work of thought and intelligence. With his great quote today, we are having same thoughtful and very intelligent personality with us, Dr. M.B. Kokre sir. Sir has finished his PhD from Department of Electronics and Electrical Engineering from Indian Institute of Technology, Kharagpur, India, and completed his postdoctoral research work in 2011 and 12 at the University of California, Santa Barbara, USA. Currently, Sir is working as a professor, Dean of Academics, Coordinator of Center of Excellence in Signal and Image Processing, and Coordinator of RUSA at SDG's Institute of Engineering and Technology Nanded. We are very fortunate to have you, sir, for today's session. So without any further delay, I would like to request to hand over the session to you, sir. Over to you, Kokre, sir.
Thank you. Thank you very much. So let me share my presentation. Okay, so is it visible now?
Yes, sir.
Okay, okay, fine. Yeah. So thank you once again for giving me opportunity to deliver a talk in the short-term training program of 5 days. So as per agenda, today I'll be talking about machine learning classifiers. Okay, and yeah, day before yesterday I talked about machine learning, basics of machine learning, then applications of machine learning, then what are the challenges of machine learning, and then what is the future of machine learning. So that is what I talked in my last lecture on Tuesday. In that lecture, I talked that machine learnings are of 4 types. Number 1 is supervised learning approach. Another one is unsupervised learning approach. Third one is semi-supervised learning approach, and fourth one is reinforced learning approach. So, in the supervised learning approach, you know that all the patterns which are there, okay, or the objects which are there are properly labeled, or from mathematical point of view, okay, we have the prior information about the events or classes and everything. Whereas in unsupervised learning, so prior information is not there, so number of classes are also not known. Whereas semi-supervised is a combination of supervised and unsupervised approach. So partially, the objects are labeled and remaining objects are unlabeled and so on. And in the fourth approach, that is reinforced learning approach, this one, you get the feedback after you get the output. So I correlated that one like as doing a PhD means when you do or when you propose or when you give some kind of solution to the given problem, and when you get the result with that one, and when you approach to your supervisor will see it's okay from technical point of view and also further applications and all those things, and then he will give you feedback. If it is right, he will give positive feedback. If it is wrong, he will give negative feedback and so on. So based on that one, you will be progressing your research. Similarly, in reinforced learning approach, once you get the output after first iteration, feedback will be given. So for positive this one output, you'll get the positive feedback, and if output is wrong, then you'll get the negative feedback. And based on that feedback from first iteration, okay, algorithm will learn again and then present the output, the improved output in the next iteration. Again, feedback will be taken and so on. So like that way, it will be a continuous process and so on. So all these algorithms, okay. So there are basically one of the part of this one machine learning step is a classifier. Okay, we'll see the particularly cycle of machine learning, and then this machine learning classifiers and so on. So there are several classifiers available. Out of that, okay, for example, I'll take you for understanding purpose, I'll take you 3 examples. One is KNN classifier, which is non-parameterized, and then okay, in K-means classifier, okay, we'll be using minimum distance classifier, and then we'll talk about the SVM and so on. So if you look, what are the different types of classifiers which are available in machine learning? So as I said that in a supervised learning approach, there are 2 types. One is a classification approach and another one is a regression approach. Okay, where regression is particularly where output is in continuous form. Okay, so that problem is called as the regression problem, and if your output is in discrete form, then that problem is called as a classification problem. Okay, so you have the classifier which is called as the logistic regression, where a statistical model that uses the logistic function to model the probability of a binary or multi-class target variables. So there probability is used, and then statistical model is developed, and which will be classifying either into 2 categories, that is binary, class 1 or class 2, or in multiple categories also, and so on. So that is one type of classifier. Second type of classifier is decision tree classifier, okay, where you make the decision, or your model makes the decision based on the rules. So you have to derive the rules, and these rules are derived with the help of training data or with the help of expertise and so on. I'll give one example here. Like for example, when we are doing a research in the biomedical field, we are engineers. Okay, so we don't know much terms about the biomedical things and so on. So we have to take the expertise, or we have to take the help from the expert people. Like for example, now I'm working on diabetic retinopathy problems since last few years. Almost last 10 years, I'm working on diabetic retinopathy problem, and almost 5-6 research scholars completed their PhD in this domain. my postdoctoral research work was also in that domain and so on. So here, as I said, when I'm working on diabetic retinopathy, I was not knowing the all those biomedical terms, okay, which are used in the used by the ophthalmologist and so on. Like for example, mechanism means what, hemorrhagens means what, then hard exudate, soft exudate, neovascularization. So many terms are there, and so for that, level 1, level 2, level 3, and to level 4. So how to classify that one? How to segregate that one? So this, okay, for that you need a expertise opinion, that is ophthalmologist. And can you believe only on one expertise and so on? So absolutely not. Even actually, when we have conducted an online challenge, and we have particularly we have developed the database of Indian diabetic retinopathy. Now, at presently, we have developed 3 international standard database on diabetic retinopathy, and based on that one, we have conducted the online challenge, and now it is available for use for all the research community and so on. Now, when we were developing that this one standard database, we have to take the opinion of experts, and then we cannot basically believe only on one expert. So generally, when we were developing that database, we used 3 experts or 3 ophthalmologists, and then when all those 3 experts were saying yes, this is a micronism pixel, or this is a hemorrhages pixel, or there is an exudate or soft exudate or hard exudate, and so on. So like that way, all those things, by considering those things, we created the ground truth. And then after creating the ground truth, okay, we conducted the online challenge and so on. Similarly, for classifying the object, okay, you need expert advice, and from that you can derive the rules, and then you can use the classifier, like if this happens, okay, this may be a case, if this happens, this may be case, and so on. So a decision tree classifier, okay, is up like that, a tree like model that makes the decision based on the rules derived from the training data as well as the expert opinion and so on. Okay, the third type of classifier is random forest classifier. So, which is nothing but the ensemble method that combines multiple decision trees to improve the performance. So here, particularly decision tree, like decision tree. So some of the output of some of the decision tree output is weak classifier and so on. And then if we combine the output of several classifiers together, the performance of that classifier improves, and that is what this random forest approach is used. The fourth one is particularly a naive-Bayes classifier or Bayesian classifier, where probabilistic model is used, and then in that priori probability, posterior probability, and then conditional probability. Okay, all those probabilities are calculated, and then classification is done. So this can be also used for a binary class or a multiple classes and so on. Then there was a champion of neural network classifier for long duration, and you know that neural network classifier, it requires a lot of time for classification and so on. So time computationally is high, and so to avoid that one, in 1991, this support vector machine came, and this is a discriminative model that finds the hyperplane in high dimensional space to separate the different classes. Okay, so in our lecture, basically we'll talk about KNN classifier, that is okay, nearest neighborhood classifier, then SVM, and then K-means algorithm. So KNN classifier is a non-parametric algorithm that finds the K nearest data points to the input point and predicts what is the output based on their labels and so on. Okay, so this support vector machine, and then KNN classifier, and then K-means algorithm, which is an extension of particularly minimum distance classifier, but that is particularly used in unsupervised learning approach. So I'll talk about, okay, I'll take one example of your supervised learning approach by using KNN classifier, and then by using K-means classifier with minimum distance classifier. I'll take a example of unsupervised learning approach, and then finally I'll talk about the this one SVM algorithm or SVM classifier and so on. So 7th classifier is a neural network classifier, which is nothing but a model inspired by the structure of human brain. I told you in my last lecture that when you like to make the machine intelligent like the human intelligence, So you know that for human intelligence, we get the data from 5 different sensory organs, and then one of the sensory organ is your eyes, then second one is your ear, third one is your nose, fourth one is your tongue, and fifth one is your skin. Out of these 5 sensory organs, we get maximum information from the visual data, that is from your eyes. So research says that almost 78% information we get it from our eyes, and remaining 22% information we get it from our 4 sensory organs and so on. Now the whole information is sent to the brain, and you know that the brain consists of several neurons which are interconnected with each other, and then when inspired with this brain model, neural network classifiers or neural network was proposed in 1979. So first neural network was proposed, and now a lot of research has been carried out in that. And this neural network classifier is particularly inspired with the structure of human brain that learns by adjusting the weights of connection between the neurons and so on. Then gradient boosting algorithm is there, classifier is there, so which is an ensemble method that trains a sequence of weak classifier and combines them to form the strong classifier. Okay, and the last one, which is nothing but the deep learning classifier. So a class of neural network here, already I told you what is the difference between the neural network or basically simple machine learning algorithm and deep learning algorithm. In neural network, you have 3 layers. One is input layer, another one is output layer, and the in between input and output there is a hidden layer. So there are only 3 layers, whereas in 2006 researchers from Toronto, they coined the term why to have only one input layer, why to have only one hidden layer, why not to increase the number of hidden layers. And then they could solve so many complex problems, and people got attracted to that kind of classifier. And this classifier particularly uses multiple hidden layers instead of only one hidden layer. But you know that when multiple hidden layers are or number of hidden layers are increased, the computation complexity will also increase. Another thing is that hardware requirement for deep learning is also intensive. Third thing is that for this deep learning approach, the data which is required is also extensive and so on. So these are, okay, overall this is a picture of classifiers which are used in machine learning. Now we'll see the basics first, and then after that we'll go step by step. Okay, so when if you look at any human being, okay, and how we recognize any kind of object as a human being, or how we learn the things and so on. Now, simple example, I'll tell you that, okay, like for example, you have this one. In my last lecture also, I talked about the example of Amitabh Bachchan and Amir Khan. So if you'd like to distinguish between these two persons, so we have to extract the features. Okay, why we are extracting the feature, why we cannot take directly image to image and then classify the object. So number one is that, okay, if you are comparing image to image, okay, so that is called as the template based approach. Now when you are comparing image to image, problem is that, suppose for example the size of image is 512 by 512, so you have to do the subtraction of 512 by 512 pixels, so number of operations will increase. Okay, so computation complexity will be also high in that case. Second thing is that, okay, if for example two classes are same, okay, two classes are same, but like for example I have these two pens, okay, these two pens are, okay, assume that these two pens are same. But now if I take the difference between the image of two pens, but if one image is shifted by 1 pixel, then in that case what will happen? So when I'm comparing that this image with this image, and if it is one image is shifted just by 1 pixel, then those two images are same, but their difference will not be 0. And then if the difference is not 0, our computer or learning algorithm will say that these two things are different, though they though they two things are same, but it is second thing is, or second object is just shifted by 1 pixel, so that is creating a problem. Then the third reason is that, like for example, I have one image of 512 by 512 image, and second image is of 128 by 128 image. Now this image and this image is same, okay, but can I compare pixel to pixel from one image to another image? Because the size of one image is 512 by 512, and the another image is 128 by 128. So if scale is changed, we cannot compare that one based on the template based approach and so on. So that will create a problem. So first I talked about like, okay, if the size of image is large, okay, computations will increase. Then if both image size is same, but one image is shifted by 1 pixel, either right or left or top or bottom, it will give altogether total difference 0. It will not give difference 0. Total difference will be larger in that case. And the third thing which I cited here is that both images are same, but they their scale is changed. Then that will also create a problem. Okay, because we cannot compare 512 by 512 image with a simple 128 by 128. The fourth problem is that, like for example, I have two images same, but one image is rotated or one image is shifted, then this rotated image I cannot compare with the original image. So that is the fourth problem. So what is the solution for that one? The solution for that one, instead of template based approach for comparing, you extract the features. You extract the features from the objects, and then after that use those features to represent that object. Like for example, you like to represent the face. Okay, so what kind of features you can extract? Like for example, what is the distance between two iris? What is the distance between left iris and upper knee, this one nose? What is the distance between left iris and then upper lip, right iris and upper lip, or lower lip, or chin, and so on. So like that way, you have got some kind of values, numerical values. Those values are called as the features, and then these features can be arranged in a feature vector form that is called as the feature vector form. So generally, when you are selecting features should be distinctive. And so that's why I said that when you are considering the example of Amitabh Bachchan and Amir Khan, so we have to select the features which are making difference between these two persons. So what is the first difference between two persons? Height of Amitabh Bachchan and Amir Khan is difference. So we can take height as one of the feature. Then another thing is that weight is also different. So we can take weight as a this one. So we got two features. Now when two features we got, so we can represent those two features in one feature in one dimension and another feature in another dimension. So when there are two features, dimension of feature space will be 2. Okay, two-dimensional feature space. But if for example, if I add another feature like as what is the voice pattern of that person. So voice pattern, okay, like for example, if we measure the pitch or any voice parameters and so on, so that will be the third value. Now we got 3 values in a vector, feature vector, and when you are representing that feature vector in a feature space, so this feature space will be 3-dimensional feature space, and then every point, okay, every feature, this feature vector will be represented as one point in that feature space. So features are nothing but the distinctive things, and then when it is formed in the vector, it is called as the feature vector in machine learning. And then when it is represented in a space, so dimension of that feature space will be equal to number of features. So if you are extracting 2 features, so dimension of that feature space will be 2. If you are extracting 3 features, the dimension of feature space will be 3, and so on. Like that way. Okay, so if number of features are increased like as a 10, so you can, okay, your feature space dimension will be 10-dimensional feature space. Now you cannot visualize the feature space beyond 3-dimensional feature space, and so on. But so that is called as the hyperdimensional feature space, and so on. And the role of classifier is to divide this basically classes into different regions. So suppose, for example, these are the feature of Amitabh Bachchan and these are the feature of Amir Khan. So, and if this is a feature 1 and feature 2, like for example, or this is suppose for example other person, normal person's features are there. This is Amir Khan and this is Amitabh Bachchan. Now here what we have to do, we have to divide this feature space into different regions, and that is the job of classifier here. So for dividing this two-dimensional feature space, you need only one line equation, right? So we can divide this feature space like this way, and so only line equation is needed for two-dimensional feature space. But when feature space become a three-dimensional feature space, at that time what happens, basically simple line equation will not be sufficient to divide that feature space, so you have to write a plane equation in that case. Okay, so then when the number of features are increased beyond 3, then you have to use the hyperplane equations and so on. So as feature space dimension increases, then designing classifier becomes difficult and so on, right? So pattern is nothing but the composite of trait or features or characteristic of an individual. So in a classification task, a pattern or pair of variable x comma omega. So x is nothing but the observation or features, and omega is nothing but a label or class. So this x belongs to that class omega and so on. So what makes, generally in a machine learning, what makes a good feature? So if features are linearly separable, see that here. See that this is one class and this is another class. So if these features are linearly separable, then designing a classifier becomes very, very easy. So just simple line, drawing one line will separate this region as one class region and this region as another class region. So this kind of features are called as the really good features, because the accuracy, whatever you will get, that will be very, very high. But if the features, see that these are the features of one class and plus sign is the feature of other class. Now, if features are mixed together, then see that if you divide this feature space into any region or by using any kind of line equation, then there will be always misclassification and the classification accuracy will not be good and so on. So here, this kind of features are called as the bad features. Okay. So this is linearly separable. Okay, it's good. If it is non-linearly separable, like for example, these are separable, but the feature, this equation is a nonlinear equation, or this line is a nonlinear equation line, and so on. So this is a bit difficult as compared to this one. Here, these features are highly correlated, means if one feature increases of one class, another feature of other class also increases and so on. So this is highly correlated. Whereas this is the multimodal kind of thing. Okay, so multimodal features are there and so on. Now, so classifier, the job of classifier is basically to divide this feature space into different regions. Like for example, there are 3 classes. So this is the region of class 1, this is the region of class 2, or this is the region of class 3. Or here, this is the region of class 1 and also this one, and the remaining region is of class 2 and this is the region of this one. So this is non-linear classifier, whereas this is the linear classifier, because lines which are used are basically, which is called the discriminating function, which is used in this classifier is a straight line, and designing this kind of classifiers are easy as compared to the designing this kind of classifiers. So this kind of classifiers particularly are designed with the help of neural network approach or deep neural network approach and so on. So whereas this kind of classifiers can be designed with the help of simple machine learning algorithms and so on. So overall, this feature space is the union of x1, x2 up to xn and so on. And this union, okay, whereas the disjoint of this one or intersection of this one should be 0, because there should not be any overlapping of x1 region with x3 region. Otherwise, if there is an overlapping of this one x1 and x3, then there will be confusion between x1 and x3 class, or between x1 and x2. If there is some kind of portion is overlapped with this one, then there will be confusion, and that will create a problem for classification and so on. So the classification consists of determining to which a region a feature vector x belongs to. So borders between these decision boundaries are called as the decision region. So this is called as the decision region. Below this one, it belongs to class 2. Below above this one, it is called class 3. To this side, it is class 1, and so on. Right. So the overall a representation of classifier is that a classifier is typically represented as a set of discriminating functions. So these are nothing but the discriminating functions. So these lines or these curves are nothing but the discriminating function. So classifier or classifier is a set of discriminating function, F1 function, F2 function, or Fy function. And then finally, you have to take the maximum decision out of that one and so on. So now, in recognition or classification approach, there are two ways. One is you can use the statistical feature for classification, or another way is you can use the structural feature, or which is called as the syntactic feature and so on. Okay, statistical features, okay, you can use the probabilities or conditional probabilities or class conditional probabilities and so on. And based on that one, you can use the classifier like as a base classifier or naive Bayes classifier, and this one support vector machines classifier also and so on. Whereas in syntactic approach, particularly if the problem is not so simple, then we can divide that this one problem into different regions, and then we can find the relation between first object and second object, and then that relation we can represent it with the help of graph, and then graphs best approach can be used to recognize the objects and or classify the object and so on. So in syntactic approach, particularly grammars, graph, automata, strings, okay, and relational descriptors are used, whereas in statistical approach, if you see the difference, okay, we'll see that one later on. So basically, in syntactic approach, you are dividing the complex problem into small regions, and then we are establishing the connection between the every region, and then that connection can be represented with the help of strings or grammar or the graphs and so on. So syntactic PR is used not only for classification but also for description and so on, right? Neural network, okay, when the problem is more complex, at that time neural network classifier is used, because you don't have to worry about finding the equation or whether it is a plane equation, simple line equation or plane equation or hyperplane equation. Automatically this neural network will divide this feature space into different regions once that neural network learns the things and so on. So NeuroPR, okay, is a trainable model and non-algorithmic, and it is a black box strategy for classification of any objects with the machine learning and so on. Now just see the example here. By using neural network, suppose this is the A pattern. As I said that for object recognition here, okay, you have particularly for alphabet recognition, you like, for example, you can extract the features like a forward slant line or backward slant line or horizontal line or vertical line or semicircle and circle and so on. So like that way, when you extracted the features, so there are 6 features. So in the neural network, particularly the input number of input neurons will be 6 because number of features are 6, and the number of output neurons will be equal to 26 because number of classes are 26. And then those features are given to this neural network input, and then neural network will be trained with several examples or several patterns. And then once it is trained, then you'll get the output and so on. So, but here it uses a black box approach and so on. Whereas in statistical approach, what do? You can extract the numerical features out of that one, and then those numerical features can be represented with a feature vector, and then after that probability based or any other approach, minimum distance classifier approach can be used, and then classification can be done. Whereas in structural, we are defining the basically this whole complex program or complex problem can be divided into simple one, and then we can find the relation between all those simple one with the original, and then after that graph-based techniques can be used. So this is the difference between the neural, statistical, and structural approach or syntactic approach and so on. Okay, so this is the simple rule-based approach kind of thing. So simple, suppose for example, consider the problem of recognizing the letters L, P, O, E, Q and determine the sufficient set of features, design the tree structured classifier. So tree structured classifier, for example, here we have extracted the features like as a vertical line, horizontal line, slant line, and then curved line. For L, vertical line is 1, horizontal line is 1, slant line is 0, and then curve line is also 0. For P, vertical line is 1, horizontal line is 0, slant line is 0, but curve is 1. So like that way, we have extracted the feature for L, P, O, E, and Q. Now, with the help of knowledge or expert advice, we can develop the classifier based on this one tree structure classifier or this one. So if you start, if vertical lines are greater than 0, yes. If curve lines are greater than 0, then that problem, or that object will be P. If vertical lines are greater than 0, but curve lines are not greater than 0, then if horizontal line is greater than 0, so this will be E object. If no, this will be L object. So like that way, you can divide, or basically by rule-based approach or tree structure-based approach, you can design a classifier, and which is very, very simple classifier in a machine learning. Now, when you are designing any machine learning or solving any machine learning problem and so on, so there is a machine learning design cycle. First thing is that you have to collect the data. Now, data collection is very, very important, and how much data is really sufficient and so on. So I'll take one example. As I told you that, we have created the database of Indian diabetic retinopathy database. 3 databases we have created, and then those databases are accepted at international level. We have conducted international level 3 challenges, and now those databases are available. I'll give one simple example here. When I was doing my PhD at IIT Kharagpur, so in IIT Kharagpur, there was one research scholar whose name was Hemant Patil. And he was our student from HGS Nanded. He did his master's, and then along with me, he joined at IIT Kharagpur for PhD in the electrical department, and his supervisor was Professor T.K. Basu. And he was working on a problem of this one, Marathi speaker recognition problem or Marathi speech recognition problem and so on. Now, the first task for solving that problem was that he should have the data of Marathi speaker and so on. Now, in IIT Kharagpur, when I was there, at that time there was a Maharashtra Mandal. Now also there must be that, because every IIT, all those state mandals are there. So Maharashtra Mandal is also must be there in every IIT. Particularly in IIT Kharagpur, when I was there as a PhD student, there were 100 students, including master students, PhD students, and undergraduate students. So 100 students were there, and then this research scholar who was working on a Marathi speaker, can he collect only a sample of 100? 100 is sufficient for carrying out the project. Another thing is that, 100 number is not sufficient for speaker recognition problem or speech recognition problem. So you should have a large data set. Then what he thought that, he will collect the data set from Maharashtra, because in Maharashtra, almost many people, or almost 95% people speak in Marathi language. Now, since he has done his master's from Nanded, can he collect the whole database? Because in Nanded, there is a population of more than 6 lakh people or 7 lakh people population is there. So can he collect the data from the Nanded for Marathi speaker recognition? Absolutely not. Because see that the Marathi spoken all over Maharashtra is having different dialects. So in Western Maharashtra, dialect is different. In Southern Maharashtra, dialect is different. North Maharashtra, dialect is different. Vidarbha, it is different. Marathwada, it is different. Konkan, it is different. Bombay, it is mixture. So if you want to develop a real world system in machine learning, your database should contain all best cases as well as worst cases. So when you are designing or collecting the data set, you have to collect the samples which will represent all the kinds of problems. And so he must take some samples from Marathwada, some samples from Vidarbha, some samples from North Maharashtra, some samples from South Maharashtra, some samples from Central Maharashtra, or Western Maharashtra, Bombay, Konkan, and all those things. So he decided that he will collect that one. Again, another thing is that can he collect a sample of any person or like that? No, because in that region itself, a small kids speak Marathi differently. Elderly people speak Marathi differently. Okay, younger speak it differently. Then male, female. Sometimes the twins are there which speaks very similar and so on. So he has to basically I didn't understood first what are the differentiation among that problem, and then try to collect the feature or collect the basically samples from that one. So whoever is working in the machine learning domain, okay, the first task is to collect the data samples, and those data samples should not be only a good samples or like that. It should be like as a balanced data. Means number of samples of good must be equal to number of samples of bad. Or somebody is working in, like for example, in a biomedical field. Okay, like for example, I'm working in diabetic retinopathy. So if I have created a database of 1,000 samples, so out of that 500 samples should be of normal persons. Okay, means which does not have, the person does not have suffering with the diabetic retinopathy, and then remaining 500 samples should be like for example 100 samples should be from level 1, level 0, level 1, 100 samples from level 2, level 3, level 4, and so on. So like that way I have samples from best case to worst case, and when I use those samples from the data to train my algorithm in a machine learning, machine will learn perfectly. Otherwise, suppose for example, if you are training that machine learning algorithm with only good samples, then this machine learning algorithm will fail when it comes to the worst samples or like that. So data collection, when you are designing any kind of machine learning problem, data collection is very important and probably the most time intensive component, because we have witnessed that when we have designed the data set or when we have prepared that data set, 3 data sets, for every data set almost it took 1 year to complete that data set. So it is a really time consuming job. So if somebody is working on the available data set, definitely he can finish his PhD or her PhD quickly. But if somebody is starting from scratch, then collecting the samples, validating from the experts, creating the ground truth, and then having the samples like as a balanced data set, and then a large number of samples. So that is really a time consuming process. Okay, one can think whether to work on the ready-made data set or you can create your own data set and so on. So data collection is one of the most important step in the this one. Otherwise, suppose for example you have taken a problem for research, and later on you come to know that now this data set is not available because the paper which was referred of that XYZ researcher, he is not sharing the data set and so on. And without data set, you cannot do the experiments. So before finalizing your topic, see that whether that data set is available or not in your research domain or okay. Otherwise, it will be just wastage of your time and so on. So otherwise, you have to be ready to collect the data set, have a dialogue with expert, create the standard data set, balanced data set, and go ahead. The next step is that what kind of features you should choose. So for that, okay, you have to you have to take the expert's opinion, because you are not expert in that domain. We are engineers, so we know how to develop the algorithm, but for success of that problem of machine learning, the right set of features must be selected, and then these features, which are the right set features, that will be told by the expert and so on. So this requires the basic prior knowledge of that problem. Here, your expert opinion is very important. Then after that, you can select whether you like to go for simple machine learning approach, which is statistical based approach, or structural based approach, or you like to go for neural network based approach, or you like to go for deep neural network approach. I'll tell you that as per my experience, I'll tell you that if the problem is simple, don't go for neural network or deep neural network and so on, because that problem can be solved with a simple machine learning algorithms by using statistical approach, or if that problem is a bit complex as compared to the statistical approach, then go for structural approach. And if the complexity increases, then go for simple neural network approach. And if complexity is further increased, then go for this one, a deep learning approach. So as you go up, like as a deep learning approach, as I told you in my earlier talk also, that when you are going for a deep learning approach, you have to be ready with the intensive hardware, large set of database, and then training time and so on. So that will be there. But definitely the complex problem, for that complex problem, you get the very good result with the deep learning approach and so on. So our third step of cycle, this machine learning design cycle, is that the choice of model you have to do. And then after that, you have to divide this data set into training and testing data set and so on. Now, what is the expected as per standard, international standard? Suppose, for example, you have a sample of 100 samples are there, or 100 samples are there in your data set. So how many samples you should use for training purpose? How many samples use for testing purpose? Some people use 70% samples for training. Some people use, and then 30% for this one. 30% for testing and so on. Now I'll tell you, I'll just correlate this simple example. Or some people use 100% samples for training and then same samples are used for testing. Okay. So which one is correct then? See, that simple thing is that we are teachers, okay, and what we would like to know, we'd like to know whether that student has understood the problem or not, or whether that student has learned the things or not, whatever we are teaching. So how we are going to test? Okay. Suppose, for example, we have taught that course. Okay. We have given lecture notes to them. And if you are asking the same problems which are there in your lecture notes, same solved problems or same theory from that lecture notes, then what that student will do? That student will just mug up that one, and then he or she will just represent that in the examination. And then after evaluation, if that student get 90% marks or 100% mark, can you say that this student has really understood 100% subject? No. See that when student, okay, basically when we can say that somebody has learned, when that person can solve the unsolved problem, when that person give the correct result for unseen events or unseen problems, the correct this one, then that will be a true learning and so on. So you must be knowing that the training, what kind of training which is given to the student, those who are preparing for JEE Advanced and so on. You must be aware that the questions which are there in JEE Advanced are not at all repeated. Okay. So the students are trained such that they can solve any kind of unknown problem. Okay. Their fundamentals are so clear. So even if you give any unknown problem, they will be able to solve that kind of problem. So definitely their performance will be really good. Okay. But the students which are just mugging up and then representing that one, we cannot give a guarantee that this student has really learned that subject or not. So similarly, in a machine learning algorithm, if you are using entire data set for training purpose, and then if you are asking, taking some samples from that only for testing, and then if you are claiming that my classifier is giving 100% accuracy or 99% accuracy, you cannot give a guarantee that this classifier will work consistently better for any unseen problems or unseen events and so on. So you cannot give a guarantee. So as per standards, okay, what is done? As per standard, this tenfold cross validation is done, and then your classifier should be tested for tenfold cross validation. Now, what is this tenfold cross validation? So like that, for example, you have 100 samples. So make the 10 folds of this 100 samples. So in every fold, there will be 10 samples. Second fold, there will be 10 samples. Third fold, 10 samples. So like that, with 10th fold, there will be 10 samples. Now, okay, how training is happening in tenfold cross validation? So 9 samples or 9 folds are used for training purpose and 1 fold is used for testing purpose. So 1 is kept out of this 10 fold and remaining 9 are used for training purpose. Once your algorithm is trained, okay, then the fold which was not used for training is used for testing, and then you note down what is the performance or what is the accuracy of that one. Then in second iteration, the fold which was kept as a testing is inserted into the training fold, and 1 fold from training is taken away. Now the training data is changed, testing data is changed for this one, again do the training, again do the testing. So like that way, this process is repeated 10 times, and then the classifier is tested 10 times. So first accuracy is for first fold, second accuracy is for second testing fold, and like that way. And then average accuracy is calculated, and then that gives basically probably a good result compared to the only one shot learning and so on, or one fold learning cross validation and so on. So here evaluation criteria is also very important. So in the training also you can use given the feature set and blank model, adapt the model to explain the data, or supervised, unsupervised, or reinforced learning. You can decide it based on the availability of prior information, and then evaluation. Okay, how well the trained model do, or whether there is a problem of overfitting or generalization and so on. So there are some kind of sub problems of machine learning also. So problem and domain dependent. So for example, or some problems requires knowledge of the domain, or some problems require a good feature extractor that will make a job of classifier trivial or easy. If there is noise, you have to remove that noise from the this one to improve the performance. If there is an overfitting problem of machine learning, so overfitting means basically an overly complex model may allow perfect classification from the training samples. But when it comes for non-training samples or novel patterns, okay, then it is unlikely to give the good classification. Means, as I said, that students are performing very well, okay, when we ask the question from the syllabus or from the notes which have been given, lecture notes which have been given. But if we ask a question which is based on the theoretical concept or this one concept, but that is not there in their lecture notes, if it is from out of lecture notes, so if they are not able to perform that one, so that will tell you basically whether they have learned really or not. So overfitting problem is that means it will give you the good result for the known, but it may not perform the way it is performing for known, so it will not perform well. So that is called the overfitting problem of your model. So then model and feature selection, and also how to decide the reject class of models and so on. And prior knowledge is also very important for the success of machine learning and so on. Missing features, so how to train a classifier or use one when some features are missing, and then segmentation problem, or you can also how to extract the invariant features that we have to decide, or then can we design several classifier and combine them to get the performance better, like as a random forest method or ensemble techniques and so on. And then what is the cost, computational cost, and what is the risk, and all those things that we have to think when we are designing any machine learning and so on. Now, in the supervised learning approach, okay, so I'll talk about now the K-NN classifier and so on. So quickly, I'll take the difference between statistical approach and syntactic approach. So in statistical approach, as I said, that you are extracting the numerical feature. In syntactic approach, we are okay, you have the characters like as a syntactic this one symbols, or this one that object can be represented with symbols and so on. So this is the qualitative approach, syntactic approach, whereas this is a quantitative approach. And from this numerical features, we can form the feature vector, which is called as the feature vector. And here in syntactic approach, this will form the language of that class and so on. So the elementary approach or elementary properties of statistically described objects are called as the features in case of statistical approach. In syntactical approach, as I said that, it is called as the descriptors. These are primitive, it is called as the primitives. Whereas it is called as the feature, here it is called as the primitives. And in statistical approach, there is no requirement of obtaining the relation between the features. So we don't have to obtain the relation between first feature and second feature, but in syntactic approach, we have to obtain the relation between first primitive and second primitive and so on, right? Then from the features, we can form the feature vector, whereas in syntactic approach, we can form the language. It is called as the language. So extracting feature is an algorithmic process in statistical approach, whereas in syntactic approach, it is not algorithmic approach. So design and descriptor primitives, and their relation is not algorithmic. And here, expert is not needed really here, whereas expert in the analysis of problem and designer experience is needed in syntactic approach. As I said that simple problem of machine learning can be solved with the statistical approach, but difficult problems can be solved with syntactic approach. If problem is more difficult, then go for neural network. If it is further difficult, then go for deep neural network and so on, right? Now, statistical approach, so you have to extract the features, like for example, you have extracted the feature of f0, f1, fn of some object, and then you have the classifiers or classes like as a C0, C1 or CM1, CM-1. So there are m classes and n features are there of those objects. Now, so for example, we have trained that algorithm, and then after that, when unknown patterns comes, so just we have to compare that unknown feature with the trained features, and then by using classifier, we can classify that objects to whether it belongs to a particular class or like that. And for that, you need a distance function. I will tell you that there are almost 50 to 60 different distance functions are there. So well-known distance function is Euclidean distance, then Manhattan distance is there, Canberra distance is there, Brackett distance is there, then vector mean variance distance is there, Mahalanobis distance is there. So like that way, see, I'll tell you that when I was doing my research at that time, Padma Shri Professor A.K. Roy, he suggested me that, many people in machine learning, they are doing that, in a classifier, they are using simple Euclidean distance for measuring the dissimilarity and so on. So one thing you can do is that just you do the study of changing the distance function. So instead of using a standard Euclidean distance, you change that. You keep the features as it is and change the distance function and see what kind of results you get. So I was working on a retrieval problem, continuous semi-retrieval problem, and then I extracted the features by using simple wavelet-based approach. And then after that, once those features were extracted, I use a simple Euclidean distance measure for classification purpose, and then I got 41% accuracy. Then after that, I changed the Euclidean distance. See, I kept feature as it is and then changed the distance from Euclidean to Manhattan distance, Manhattan to Mahalanobis distance, Mahalanobis to Brackett distance, vector mean variance distance, and so on. So like that way, at that time in 2003, I did the experiment of 9 different metrics. And surprisingly, what my observations were there, see that I kept features same, and then I was just changing the distance function to see the output, and then with simple Euclidean distance, I was getting 41.41% accuracy by same feature, and then I changed my distance function from simple Euclidean to Canberra distance. The retrieval accuracy was improved up to 30%, means basically the new retrieval accuracy was 71%. So it has been improved from 41 to 71% just by changing the distance function. Then my job as a researcher was that, okay, why this basically improvement is there? Just I change the distance function. So if you look at the mathematical model of the distance function of Canberra distance, so that mathematical model basically do the normalization of the things. So normalization of the feature, and if normalization of the feature is done, then if there is minor changes in that one, so it will be automatically handled, and then it will not give the wrong result and so on. That's why retrieval accuracy was improved. And then after that, I wrote a paper and then communicated that one to IEEE 10con 2003 conference, and it was accepted at Bangalore. And then after that, this paper got several, almost I think 264 citations. Only for that paper I got. Total my citations are around 3,000 citations are there, and now top citations are to our IDRID database. Then second citation is my IEEE transaction paper, and third citation is to this paper, particularly a conference paper, but it is referred by many researchers, because earlier researchers were using only a simple distance function like as a Euclidean distance. But when I explored all those things, then people also started using the different distance functions. Later on, one of the research scholars, she used 50 distance functions for fingerprint matching, and then her paper was also published in ISAPRI journal. And so distance function also plays a very, very important role in machine learning and so on. Now, simple, for example, what is the distance, or what is the feature vector to feature vector distance? So it is the distance between the member of one class and a member of other class. Like for example, as I said that this is the cluster of Amitabh Bachchan and this is the cluster of Amir Khan. Like for example, 5 people have obtained the features or measurements, and these 5 people's features are represented here, and then 5 people for Amitabh Bachchan is also represented. Now distance between this feature vector and distance between this feature vector is called the feature to feature vector distance. Okay, now the features captured or observation captured by every person will be different, because there is a change of weighing scale or other this one. So there may not be exactly same. So that will form the cluster, and then individual point is called the feature, and then distance between individual point to point is called the feature to feature vector. Whereas feature vector to class distance, so it is the distance between the member of one class and member of other class. So another form of distance measure could be the distance measure. Like for example here, now when you are representing this class, so this class means you have to have these members are there. So you have, how this class will be represented. So the centroid of that class will be the class, representation of that class. Also centroid of this class will be representation of this one. So when you are measuring the distance between the class and one feature, so that is called as the feature vector to class distance. Then intra-class distance. Intra-class distance means within a class. Okay, if features are totally different, then that distance will be larger. So for good classifier output, the feature should be compact. So intra-class distance should be minimum. Okay, so intra-class distance is the maximum distance between one feature of one class and another feature of or one member and another member of that same class. Okay, so what is the maximum distance? So it should be as minimum as possible. Then inter-class distance is basically, okay, this one feature vector to a class distance is basically the distance between two classes is called as the inter-class distance, and so on. Now I'll come to this performance evaluation and so on. So what are the measures which are used in a machine learning, this one? So accuracy is one of the performance measure is there, then F1 score is there, then precision is there, recall is there, confusion matrix is there, and then ROC is there. So there are several performance measures. Out of that, like for example, most of the time in a machine learning, when you are doing a research work in a machine learning, so definitely they will ask you whether you have done done the analysis with the help of confusion matrix or not. So confusion matrix is particularly, like for example, these are the classes like original actual classes, and these are the assigned classes. Now it is expected that for 100% C0 class should be assigned as a C0. It should not be assigned as a C1. So actual class is C0, and if it is assigned as a C0, then this cell will get the maximum hit. right? But if your classifier is not performing, means actual problem or actual sample is from C0, and if it is assigned to CK, then that will be misclassification. So if you look, if you plot this, or if you display the table of this confusion matrix, so from that table, you should get these diagonal elements or entries should be largest entries in that, and off diagonal should be as minimum as possible. So from that confusion matrix, we can conclude whether your classifier is really good or bad, and so on. Right now, KNN classifier. Now, see, it is the minimum distance classifier. Means it will find the distance, minimum distance between two classes, two feature vectors. Now, here, K means basically how many minimum nearest values you are considering. That is, like for example, for instance, calculate the distance from training points. Like for example, distance between x1 and x2. So this is the x1 class, for example, and then this is the x2, this one. So you are calculating what is the distance. Suppose, for example, this is the unknown problem. So what is the distance between this one, the distance between this one, and so on. So which are the nearest of this class? So this is unknown problem. So definitely, like for example, what is the nearest value, nearest distance between this one? If you are considering 2, so if you are considering 2, so this problem or this point and this point will be having nearest, this point and this point will be having nearest. So whereas other class or other this one, so this will be the larger as compared to this one. So this unknown problem or unknown sample will be assigned to this red class, because if you are considering K as a 2, in that case, the two samples of this red class are very close to this black class as compared to the green class. Okay, so if you are considering 3, then also here, basically, suppose for example, the next third one is this one. So this is the nearest one. But out of these 3, like for example, this one, 2 are from this red class. So still your this one black sample will be assigned to the red samples or a red class or like that. So in that way, this KNN classifier works and so on. So assign the label of majority. So basically K equal to 3. If you are considering K equal to 3, so for this problem, these are the basically 3 nearest value, and out of this 3 nearest, okay, 2 are from red samples. So unknown sample and only 1 is green. So unknown sample will be assigned to a red, that is on majority, based on majority. So the classifier, K nearest neighborhood classifier, is what you have to do. You have to basically extract the features, like suppose for example, there is a pair of n pair of x1t1 or xntn and so on, and then xi takes all the real values, that is nothing but the features, and ti is nothing but the classes. So each xi is the outcome of the set of measurable made upon the ith individuals, and then each ti is nothing but your class. Now whether this xi belongs to ti, so that will be decided. I'll take simple example here, like you have to give the admission to some student. Like as I take the example of giving admission to the 5th class student. Okay, this is the newcomer, whether we should give admission to that student or not. So for generally giving admission, a entrance examination is conducted. Like for example, in this school, entrance examination of English and mathematics was conducted. Okay, so entrance examination of these 2 subjects was conducted. And suppose that we have the marks of classification result of 5 applicants in the table. So earlier we have the marks which applicants are accepted in that school and which applicants are not accepted in that school. And suppose for example, a new, like for example, if an applicant has been accepted, this is denoted as class 1. So this student will be given admission. Otherwise, if it is not given, so it will be considered as a class 2. So use the nearest neighbor rule to determine. Now this Anil is appearing for this test. We have already a data of how many students have been given admission and what was their result, and how many students who could not get the admission and what was their result. Now Anil has given the entrance test and he got the marks in mathematics as 70 and in English also as 70. Now we have to check whether Anil will get admission if we consider the K value equal to 1 initially. Okay. Now this is suppose, for example, this is the data. So applicant 1 or candidate 1 who got English marks as a 80 and maths mark as a 85. So for this student in that school admission was given. One class means admission is given. But second student who got English marks 70 and maths 60, he was denied. So his class is 2 means admission is not given to him. Third one 50-70, he could not get. Third one 90-70, he got admission. Fifth one is 85 and 75, so he got admission. So out of this 5 students, okay, 3 students got admission and 2 students could not get admission because of their lower marks. Now Anil is there who has a marks like as a 70 marks in mathematics and 70 marks in English. Now if we consider K is equal to 1 means nearest value equal to 1, in that case whether we should give admission to Anil or not, that is to be solved. And for that what we have to do, basically we have to calculate the distance between Anil's marks and 5 applicant. So here distance between Anil and first applicant, English mark and mathematics mark. So 70 minus 20, consider this as a square. Okay, don't consider that as a multiplying. So 70 minus 20, 70 minus 80 square. So that is 10 square means 100. 70 minus 80, 85. So 15 square means 225. Okay, so that will be equal to 325. Similarly, Anil's marks is compared with second one. So this distance you got 100. Then third one you got with 400, and fourth one you got 400 distance, and fifth one you got 250. Now K is equal to 1. Now which is the nearest one? So nearest one for Anil is second student. Now what is the second student? Second student, he was denied admission. So if you are considering only K equal to 1, in that case Anil is very close to the second student, means Anil will not get admission based on that one, right? Now see that. So find the minimum value of D1, D2, D3, D4, D5. So where D2 is 100, and look for the value of class for number 2 applicant, which is 2. That is hence the applicant is determined as not acceptable by the algorithm, not giving admission. But now instead of comparing, instead of keeping value of K is equal to 1, we will keep value K equal to 3. Okay. So what happens basically? K equal to 3. So generally now why we are taking odd values? Because we have to take the voting of that one. If you keep the even value, then there may be a tie and so on. So that's why the value of K is generally taken as an odd. So an obvious extension of nearest neighbor rule is the K nearest neighbor rule, and this rule classifies the new sample X by assigning it the label most frequently represented among K nearest samples, and will restrict our discussion on these 2 classes. So a decision made by the examining label or on the K nearest neighborhood or taking vote K is odd. Otherwise it will, if you take the value of K as an even, then it will be ties and so on. Now calculate that one. So distance will remain same. Now just see that if K equal to 3, so you are comparing Anil with the 3 nearest. So 3 nearest, which are very nearest, 101, that is D2. Then next one is D1, and last one is D5. So first, second, and fifth student, okay, is okay. He's very close to that one. So look at the values of first, second, and then this one, these 3 values. So definitely you have a class like as a 1 for first one, second for class 2 as a for second sample, and 1 as fifth one. So because this is also 1, this is also 1, okay, and then this is also, this is 2. So here out of this majority is 1. So here Anil will be given admission because here majority is class 1, because it is matching with the admission given to that student. Like for example, here see that it is matching to the 1, then 2, and then this 1. So 1 to 1 means basically 1 and 1 is nothing but giving admission. So there are 2 1s and 1 2. So 2 versus 1 voting. So definitely Anil will be getting admission. Okay, based on his marks, but when k is considered as a 3, means 3 nearest neighborhood and so on. So like that way KNN classifier works. Okay, so that is about KNN classifier. Then we'll see the K-means algorithm, which is nothing but the unsupervised learning algorithm. And here also we can use the minimum distance classifier in K-means algorithm. So what is basically a difference between supervised and unsupervised learning algorithm? So as I said that in supervised learning algorithm, priori information is there. That is, you know the number of classes, or you know the number of samples. All those samples are labeled and so on. But in unsupervised learning approach, samples are not labeled. Okay, so priori information is not there and so on. So here in unsupervised learning approach, clustering techniques are used. So clustering is a machine learning technique that is used to place the data element into the related group without advanced knowledge of the group definition and so on. Okay, so here clustering principle or criteria is that in unsupervised learning approach, sometimes called as the classification by region, sorting by psychologists, and segmentation by people in the marketing. So you have to organize data into classes such that there should be high intra-class similarity and low inter-class similarity. So distance between the intra-class distance should be minimum and inter-class distance should be maximum, so that you have to use that criteria for classifying and so on. So clustering is nothing but grouping the similar object together. Like for example, this is one object class, this is another class, and then this is the third class and so on. So grouping those objects together and so on. So this is the intra-class distance, right? And then minimizing that intra-class distance, and then distance between two centers of this two classes is called as the intercluster distance, or this is called as the interclass distance or intercluster distance and so on, right? Now let us take, suppose for example, where it is used in clustering problem where it is used and so on. So example one is that group of people of similar size together to make the small, medium, or large t-shirt. See that when you go for purchasing the t-shirts or shirts, ready-made shirts or pants, so you get, suppose for example, the dresses like as this is a small size dress, or this is the medium size dress, or this is large size dress and a large size t-shirt and so on. So this is okay, basically fitting for many people. We are not tailoring that t-shirt for individual and so on. So this is tailor made for each person, too expensive, but one size fits all. Okay, which is basically large size t-shirt will be for larger people, medium size and so on. So here expense, it will be less expensive and so on. So generally the clustering technique, like for example, we are grouping the large size people, then medium size people, and then small size people. And for this large size people, one t-shirt, medium size people, another t-shirt, and then small size people, third t-shirt, and so on. And we are not making a tailor made for every person, and then large production can be possible in this one. So by using clustering technique, we can do it this one. So in marketing, suppose for example, segment customers according to their similarities. Like for example, okay, high class area, the middle class area, or this one low income group area, and so on. So based on that one, the LIC agents also can target their things and so on and so on. Now, where we can apply the unsupervised learning approach, so it is used in marketing for finding the groups of customers with a similar behavior, and given a large database of customer data, obtaining their properties and past buying capacities, or it can be used in biology for classification of plants, animals, so unsupervised learning approach, or even in library also you can use, in insurance sector also you can use, in city planning also you can use, in earthquake studies also you can use, in World Wide Web for document classification or clustering weblog data, or to discover the group of similar access patterns. These clustering techniques or unsupervised learning approaches are used and so on. So here, like for example, what is the natural grouping among these objects? So definitely we may feel that, okay, according to the gender, there will be natural grouping of male and female. Or if we change the criteria, like for example, in my class, Okay, if I'm teaching to the class of undergraduate with strength is 60, so if I make a gender-based criteria like how many girl students are there, how many boy students are there, okay, so that will be 2 clusters. But before, instead of that one, if I change the criteria, like for example, I'd like to have the students who got more than 9 points, 9 pointers, students between 8 to 9 points, student between 6 to 7 points, student below 5 points, and so on. So like that way, we can make the groups, different groups based on the different criteria. So here, like for example, clustering is subjective. In unsupervised learning approach, clustering is subjective. So like for example, if you make the doctor's family, so in that doctor's family, there will be male, female, company employee, male, female. If you are based on this one, your gender, that will be male and female. So this same data is having different types of cluster depends upon what kind of criteria you use. So this is whole thing depends upon the user and so on. So clustering is basically a classification of object into different groups, or more precisely partitioning of the data set into subset or cluster, so that data in each subset shares some common trait, often according to the defined distance measure and so on. So there are two approaches. One is hierarchical approach or bottom-up approach or top-down approach, and second one is Kemi's algorithm or partitional clustering approach. So here in basically hierarchical approach, bottom-up approach, basically the algorithm begins with each element and separate the cluster and merge them into successively larger cluster and so on. Or in top-down, they divide. The divisive algorithm begins with the whole set and then partition into different clusters and so on. Whereas in this partitional clustering algorithm determines all cluster at once, and they include Kemi's algorithm or Fuzzy-Simmons algorithm and so on. So here, as I said that for this this one, particularly unsupervised learning approach, also you have to use the distance metric functions. So there are several distance functions available as a Euclidean distance or Manhattan distance or Mahalanobis distance or Canberra distance. So several distance functions, are 50 distance functions are there. So it is your choice which distance function you can use for that one and so on. Now come to the point of K-means clustering algorithm. Now K-means algorithm is an algorithm to cluster the n object based on the attributes into the k partition. But now see that, like for example, if I have 100 objects, so I cannot classify those 100 objects into 100 classes, because see that this k value should be less than n. So that is the this one. Now come to this algorithm directly. Okay. K-means algorithm. So step one is that we have to begin with the decision on the value of k equal to number of clusters. So how many number of clusters should be there? So that we have to decide first. So put an initial partition classifier the data into k clusters. So you may assign the training samples randomly or systematically as the following. Like for example, take the first k training sample as a single element cluster, then assign each of the remaining n minus k training sample to the cluster with the nearest centroid. And after each assignment, recompute the centroid. So every time you have to calculate the centroid. So initially you are assuming 2 samples as the centroid of 2 classes, and then remaining samples are assigned to this class or that class. Then centroid of that both the class will change, so you have to recalculate that centroid, and once you calculate the centroid, again you have to reclassify that one, again your cluster will change, again you have to calculate that centroid. So how long you have to do? Still you get the same centroid, or if there is no jump of one member of one class to another member of other class and so on. So like that way, once the members in that cluster are same or there is no change, your centroid will be remain same, and then grouping will be done. Now this is more clear with this example. Like for example, these are the samples, 7 samples are there, and we are using k equal to 2, that is 2 clusters. Now I'm considering this as the first as one centroid of one class, and then fourth as another centroid of another class. So this I have used. So this sample as a one class and this sample as another class. So group 1 is one individual one. What is the feature of that one? 1 and second feature is 1. So 1 and 1. What is the feature of this group 2? So which is nothing but the member 4. And then what is the feature of that one? 5 and 7. Now what I'm going to do in the first iteration in the Chemis algorithm is that I'm going to classify all those 7 members or 7 samples to whether it belongs to group 1 or group 2. So how to do that one? So find the distance between this one and then this one, and also this one and then this one, and then second one and this one, second one and then this one. So like that way. So you have to do all samples. You have to calculate the distance between all samples and then centroid and so on. Now see that here we have that one with first iteration, first sample. The distance between the first one and first one is 0, but the first one and fourth one is 7.21. Then distance between the second one and first one is 1.12, and second one and fourth one is 6.10. Third one and first one is 3.61, and here also 3.61. Fourth one and first one is 7.21, and fourth one is 0. So like that way, see that this is the minimum distance compared to this one. So these 3 samples are assigned in a one cluster, and these 3 samples are assigned because this distance is less than this distance. Now here there is a tie between this one and this one. So for benefit of doubt, we have taken this third sample in a cluster 1, and then these 4 samples we have taken in a cluster 2. Now cluster is changed because earlier centroid was 1 1 for cluster 1. Now this is changed because there are in one cluster there are 3 samples, and in another cluster there are 4 samples. So we'll change the centroid of that one by taking the average of first feature and average of second feature. So this will be new centroid of cluster 1, and then this will be new centroid of cluster 2. So like that way, you got the 2 new centroid of the clusters, and then again you have to find out the distance between the new centroid and all samples. So in the second iteration, you got the distance like as 1.57 with the new centroid and class 1, this first sample, and then 5.38. So like that way. Now this, see that in the second iteration, only 2 samples are there in class 1, and the third sample, which was earlier in class 1, group 1, is jumped to the group 2. So this is now modified. So this first cluster is losing 1 sample, and it is jumping to the another cluster, and you got the different altogether different clusters. So again you have to modify the centroid of this class and also centroid of this class. So similarly you got 1 and 2 and 3 4 5 6 7. So again you have to calculate the centroid of these 2 and then centroid of these 5, and then find out the classification. So after that you got that these 2 samples remain in class 1 or group 1, and then 5 samples remain in group 2. So there is no change of samples or members from one class to another class, and because of that centroid will not change, and here we have to stop for calculating this one. So final conclusion is that these 2 samples will be in one class, these 2 samples will be in forming the another cluster, so that will be another class, and so on. So these are the things, like for example, right? What are the weakness of Chemis cluster clustering algorithm? When the number of data are not so many, initial grouping will determine the cluster significantly. Then the number of cluster K must be determined beforehand. Okay, and we don't know how many classes are there, so that is really disadvantageous, and so on. We never know the real cluster using the same data, because if it is interrupted in a different order, it may produce the different cluster if the number of data is a few, and so on. Okay, and also it is a sensitive to the initial conditions, and different initial conditions may produce the different result of cluster, and the algorithm may be trapped in the local optimum, and so on. So then what are the applications of K-means algorithm? So applications of K-means algorithm are, okay, it is relatively efficient and fast. So it computes results in order of TKN, where N is the number of objects or points, K is the number of clusters, and T is the number of iteration. K-means clustering can be applied to machine learning or data mining, used on acoustic data, in a speech understanding to convert waveforms into one of the K categories. Okay, or also it is used for choosing the color palettes on old-fashioned graphically display devices and image quantization and so on. Okay, now second, the last point of my talk is basically this one, support vector machine. Okay, so if you look at the support vector machine, see that the earlier champion of, see that earlier in machine learning, earlier people were using simple statistical approach or syntactic approach, and in that they were using simple minimum distance classifier or KNN classifier or parameterized classifier or non-parameterized classifier and so on. Then later on, to solve the complex problem, this one, 1979, this neural network came, and then with the help of neural network, people started solving the complex problems as compared to the simple problem and so on. But you know that in neural network, training the neural network is a really computationally inefficient, and then it requires large amount of time and so on. And also it requires a large amount of data for training and so on. So that was started in 1979 and so on. So it was continued up to 1992 and so on, or even after that people were studying neural network, different algorithms or different architecture up to 2006, and then from 2006 onward this deep neural network concept came and so on. But now in between, in 1992, the support vector machine concept came, which is supervised learning algorithm, and this is developed by Vladimir Wapnick. Okay, so he introduced that concept, and it is said that this Wapnick has mentioned its idea in 1979 in one of his paper, but major development was happened after 1990s and so on. Okay, so for many years, neural network was the ultimate champion for solving the complex problem. Okay, it was the most effective learning algorithm for solving the complex problem and so on. Because see that if complexity of the problem increases, simple machine learning algorithm fails there, or if your features are not linearly separable, your simple machine learning algorithm fails there, and then you have to go for the neural network approach or like that. But as I said, that neural network also creates the problem of computational complexity and so on. So people were using that neural network to solve the complex problems. So many years, neural network was the ultimate champion. It was the most effective algorithm. But in 1992, this SVM concept came, which was proposed by Wapnick. And then this became more popular after the paper which was published in 1998. SVM became more popular because its success in handwritten digit recognition, and it gave the accuracy that is comparable to the statistically sophisticated, carefully structured neural network. Means this is a simple supervised learning approach, but okay, not neural network, and then it was giving accuracy like as a neural network and so on to solve the complex problem, and the computational complexity was less. And then later on, people started using this SVM for solving the several problems. So SVM has successful application in many complex and real-world problems such as text and image classification, or handwritten recognition, or data mining, or bioinformatics, or medicine and biosequence analysis, and even in stock market prediction and so on. Okay, so in many of these applications, SVM is the best choice. Okay, now in short, I'll tell you that why this SVM is so popular? Because a support vector machine is a binary classification algorithm. It can be also extended for multi-class problem, and the SVMs are important because number one, theoretical reason is that it is robust to very large number of variables and small samples. Means we can develop the algorithm, or we can get the good results even the number of samples for training are less. You don't need many samples as neural network, and you get very good result with that same small samples. So if your problem is of small samples and it is of complex in nature or nonlinear in nature, which cannot be solved with the simple machine learning algorithm,
And this is not sufficient for neural network, because in neural network you need a large samples and it can solve the complex problem. So for that problem you can use the SVM, support vector machine, because where it can handle the nonlinearities as well as it can it needs only small samples for training purpose, and so it can learn both simple and highly complex decision functions, as I said, that whether it is a linearly separable or non-linearly separable, and also it is a powerful regularization principle to avoid the overfitting. Overfitting, as I told you, that the classifiers which works very well for the known samples but performs very poor when unknown samples comes. But here SVM gives best result even unknown samples are there, or whether samples are not at all used for training purpose. Those samples are also classified in a right way. So this is superior empirical results are there in SVM and so on. So there are three main ideas particularly. Okay, the three main ideas are like see that, for example, here you have two class problem. One is basically a cancer patient and another one is a normal patient, and so you have the gene X and gene Y, and so this is in two-dimensional feature space it is represented, and this is the discriminating function or decision boundary which is set by the classifier. And then this decision boundary, ideally this gap should be large, okay, so that misclassification will not happen and so on. Now the main ideas of support vector machine is that, like for example, as I said, that when the simple machine learning algorithm will work, that if the data or classes are linearly separable, but now here see that this is a one class, that this is a tumor class, and around that one a normal class is there. Now if I set a decision boundary like this horizontal line or this one like this way or that way, every time what will happen, basically this will create a problem of misclassification, because normal will be classified as a tumor, or tumor will be classified as a normal, and that will be very, very dangerous from medical point of view. Now so simple machine learning will not work. Second thing is that if number of samples are less, your neural network will also not perform well, or deep neural network will also not perform well. But you can use the support vector machine. So here what you have to do is that you have to use the simple kernel trick, that you map this data, okay, by using a kernel function into higher dimension. Like see that here, what was the dimension of this feature space? It was two-dimensional feature space. Now this two-dimensional feature space is mapped to the three-dimensional feature space by using Gaussian kernel. Now see that this data is represented like this, and now the dimension of this feature space is three dimension. This is one dimension, second dimension, and third dimension. Now this feature space can be divided into two classes. Okay, so this plane above that one, this is a tumor class, and below that one there is a normal class. Now here, if you design this plane equation with the help of this support vector machine, and then classification accuracy will be 100% in this case, whereas earlier case it was very, very less. So the first trick in the support vector machine is that increase the dimension of feature space by mapping with some kind of kernel function, so that will solve a non-linear problem into a linear problem. So if such linear decision surface do not exist, the data is mapped to the higher, much higher dimensional space or feature space where the separating decision surface are exist, and the feature space is constructed by very clever mathematics, like as a kernel trick in that. Now, in short, I will take this, what is the mathematical concept which is needed. So you know that particularly when you are extracting the features, those features are represented in a feature space. Like simple, for example, you have systolic BP of 110 and age is 29. So if you take age on y-axis and systolic BP on this one, so 110 and this 29, this is the cross section of this one. So this is just point. Now this is a feature vector of 110 and 29. Now this two-dimensional feature vector, if it is represented in a feature space, it will be represented as a point. So generally, right? So this is like, for example, you are representing different points in a feature space with different values. Like for example, 150 cholesterol or systolic BP is 110, and age of that person is 35. So tail of the vector will be 0, 0, 0 in a feature space, because this is three-dimensional feature space, because you have three parameters here, and the arrowhead will be these values. So arrowhead will be these values for first patient, right? So this is represented as a single point in a feature space, right? Now, as I said that when you are dividing this feature space in a classifier, if feature space is of two-dimensional or two space is there, then this can be divided into by using simple line equation. Whereas if feature space is of three-dimensional or three feature space is there, then line equation is not sufficient. So you have to use the plane equation. So plane is used there. Okay, and like that. So the simple mathematics which is used for designing this classifier, like as a multiplication of the vectors, or addition of the vectors, or division of the vector, or subtraction of the vectors, so that everybody knows this one. So just like, for example, if this is a multiplication, a vector is there, initially 1, 2, this is the a vector. If you multiply with 2, so it will be represented as a 2 and 4, and then this will be represented like this. If it is multiplied by -1, it will be represented like this, and so on. Similarly, addition of two vectors, okay, you get this a vector and this is the b vector. Addition of that b vector, a plus b, will be the new vector. So that is nothing but the addition vector. Subtraction also, if there is a vector and this is a b vector, so subtraction of a minus b will be the third vector in a feature space, and so on. Then Euclidean or L2 norm means we are calculating the distance between two values. Like for example, a1, a2, an is there, and then Euclidean norm will be just, okay, taking the a1 square under root a1 square plus a2 square up to an square, and this is also called the L2 norm in a machine learning language. So if a is 1 and 2, then its L2 norm will be equal to 1 square plus 2 square, that is 1 plus 4, that is 5 under root 5, that is equal to 2.24. So if this a vector is this, and then its Euclidean, okay, this L2 norm will be equal to 2.24, all so on. So dot product, everybody knows dot product, and then cross product, okay. And see, as I said that decision hyperplanes and this one in a two-dimensional feature space, this this feature space will be divided with only simple line equation. In the R3 space or three-dimensional space, it will be divided into a this one by using a hyperplane, okay, or plane equation. And if it is more than three-dimensional space, then that space will be divided with the hyperplane, and so on. Now the equation of hyperplane is simple. Like for example, R3 space is there, so this basic equation particularly is used in a this one your SVM. So suppose, for example, you have the defined vector x0. x0 is OP0. Okay, so this is the vector OP0, and x vector is there, which is nothing but the OP. So this is one vector x0, and this is another vector xp. Now P is any arbitrary point in the hyperplane. So this is three-dimensional space. A condition for P to be on the plane is that x minus x0 is perpendicular to W. So this is the condition to be on a plane. So a W into x minus x0 must be equal to 0. That is this one, because you know that the W into this x minus x0, so that angle between this one is 90, and the dot product between W and x minus x0, so you know that the cosine cos of 90 is 0 now. So W into x minus x0 equal to 0, or you can just simplify this equation. So W into x minus W into x0, that is equal to 0, and define this W into x0 as a B. So the equation for this one will be equal to W into x plus B equal to 0, and the other equation also hold for even the your feature dimension space is more than 3. So this way this hyperplane equation is found, and then this one the problem can be solved, and so on. So then generalization versus overfitting. See that a classifier or a regression algorithm learns to according to predict correctly learns to correctly predict output from a given input, not only in previously seen samples, but also in previously unseen samples. So this kind of output if you are getting, then your classifier is generalized classifier. But overfitting means what? A classifier gives better result only for the learned known samples, but performs very poor. Then that is called as the overfitting problem, and so on. Okay, so in support vector machine SVM, you have to design or you have to find out the line equation, or you have to find out the plane equation based on that condition of this w dot x plus b, and this holds for every this one. Okay, now see. For example, how many separating lines are sufficient, like separating hyperlines? So this is really a right choice for dividing these two classes. This is one class and then this is another class. So there may be, like, for example, I may have this line, I may have another line, and so on. So like, for example, this is one choice of hyperplane, or this one separating discriminating function, or this may have this one. So that is also correct, or this is also correct, or this is also correct. So which one is correct particularly? So which decision boundary you will choose among that one? So here the gap is maximum. Okay, so that decision boundary one should choose. So which one we should choose? So where basically, like for example, suppose we choose the hyperplane like this. Okay, and which is very close to the some sample of xi. So it is some sample of xi. Now new sample comes x dash, okay, which is really of this category, but because of this hyperplane or because of this decision boundary, this sample will be classified as a class 2. So which is nothing but the misclassification, which will be misclassified. Now if we change, so this is poor generalization. Okay, if we change this boundary to at this place, then definitely this new sample will be classified to this one. And so the position of this decision boundary is changed. And now this sample will be classified as a class 1, not as a class 2. So which is good. So this is good generalization problem, and so on. So the SVM idea is to maximize the distance between the hyperplane and closest sample points. So here we have to see, can we take this as a decision boundary, because this is close to this one or this one. So this distance and this distance is not same. So this will not be sufficient. So we have to change that one. Can we take this one? This will be minimum. This will be maximum. No, it should be maximum from both sides. So the optimum decision boundary will be like this, where there will be maximum distance will be there from both classes. So this decision boundary will be the optimum decision boundary in a case of support vector machine, and then that will give the correct result. So in SVM, this maximization is done, okay, of margin, and then sometimes there may be a problem of outlier also, that we have to take care of that outliers. Okay, so this margin we have to increase, and then we have to set the decision boundary, and so on. So by using that equation, same equation of W transpose X plus B, so equal to 0, this is valid for 2-dimensional or 3-dimensional or n-dimensional space, and so on. And based on that one, this decision boundary is finalized in a support vector machine, right? So this is the mathematics behind that support vector machine. So another thing is that by using kernel trick, as I said, that you can basically first trick is that you have to maximize the distance between decision boundary and the samples of classes. Second thing is that you can use the kernel trick, and you can basically map this lower dimensional data. See that this is the 2-dimensional data. This is mapped with the 3-dimensional data with the help of Gaussian kernel. And now after mapping, see that here we were using only line equation or line for classifying that one. But here we are going to use the plane, because this is a three-dimensional data. So dividing that three-dimensional, we need a plane. Line is not sufficient. For higher dimensional, we need a hyperplane and so on. So like that way, this was a data is not linearly separable in the input space. Now after mapping this one and to the higher dimension, this become a linearly separable. So the things which were not linearly separable in lower dimension becomes a linearly separable in a higher dimension by using the kernel trick. So that trick is used in a support vector machine for solving the nonlinear problem and so on. So nonlinear SVM mapping data to the higher dimension. So key idea is that map our points with a mapping of function phi of x to a space of sufficiently high dimension so that they will be separable by the higher dimension and so on. Now see, for example, you have one-dimensional data is there, so which is non-linearly separable. Like for example, this is of one class, blue one is of one class and red one is of another class. Now this is on a one-dimensional data, this one space. Now if I take a decision boundary like this one, so these four will be classified as a class 2. If you consider blue one as a class 1 and red one as a class 2, and if I take the decision boundary like this, then this will be classified as a class 2, but this will be classified as a class 1. So there will be misclassification. If I take the decision boundary here, then what happens? This will be classified as a class 2, but blue one will be one blue will be classified as a class 2, and then these 4 will be classified as a class 1. So even if I take the decision boundary, then what will happen? Okay, there will be totally misclassification. So idea is that we can map this one-dimensional data into the two-dimensional data and we can increase the accuracy. Like for example, map with the function f of x square, okay, x and x square. So like that you have a data like x data is there on x axis and make the square of that data. So square of that data. So if you plot that x and x square, so one axis is x, another axis is square, x square. So this data in a two-dimensional space, now this is one-dimensional and then this is a two-dimensional space, this will be mapped like this. And now we can have a line like this. So below that line, it will be class 1 and above that line, it will be class 2. Now see that the misclassification problem which was there in an original dimension that has been reduced like as a classification accuracy is 100% here by just changing the dimensional or mapping lower dimensional data to the higher dimensional data. So this is the one-dimensional data which is mapped with the higher dimensional data, and the function which is used is just x squared function we have used here. And this problem is really solved. This kind of problem is really solved, and computation complexity also not and so on. So there are kernel tricks which are available. So there are several kernels available, and okay. So you know that just I'll show that how many kernels are there. So linear kernel is there, Gaussian kernel is there, exponential kernel is there, polynomial kernel is there, hybrid kernel is there, sigmoid kernel is there. So you have to use the kernel as per your problem, okay, as per your data. So choice of kernel is your as per your data and so on. Now, what are the important? So some of the kernel issue is that you have to basically if the margin is low, because see, these are the outlier cases. So this one and this one or this one is outlier cases. So because of that, margin is low in a support vector machine. And what we want a large margin so that accuracy will be larger. So in this case, what we can do to solve this kind of problem is that these outliers you can neglect those outlier and consider another features or vectors as support vectors for that one, and then design a support vector machine according to that one, and there you will get the maximum margin in that case and so on. So soft margin, by using basically just neglecting the outliers, you can increase the this one margin and so on. So that is one of the trick. Or you can use the nonlinear model for selection of this one. So Gaussian radial basis or a low degree polynomial kernel is good to start, and also Gaussian kernel radial basis, okay, Then support vector machine can be also used for multi-class problem. It's not only binary classes, but it can be also for multi-classes. How we can do that one? So in that case, the idea is that when you are considering one class, then remaining other class you consider as one class. Okay, and classify those things. Then for this one, when you are considering other class, remaining classes you can consider as one class. So like that way, there are two basic approach. One is solve q class problem when q is greater than 2 with the help of support one versus other. As I said, that works by constructing the regular SVM WI for each class I that separates the class from all the other classes. That is, class I is positive and not I negative. So then we can check the output of each of the Q SVM classifiers for our input and choose the class I that is corresponding SVM and the maximum output. So one versus other you can, and then pairwise one-to-one classifier can be also done for multi-class problems. So we construct the regular SVM for each pair of classes, and then we can use max-min voting strategy. We test each SVM to the input, and each time SVM chooses the certain class, and we can solve that problem. So both mentioned methods above give the average comparable accuracy results, and sometime for certain application one method may be preferable to other, so it depends upon the problem. And then advantage of SVM is that based on the strong and nice theory, as I said, that advantage of SVM is that it will work nicely on small sample test. Okay, you don't need large number of sample tests. And then in case of neural network, you need a large number of samples for training purpose. Here you need a small number of samples. Here neural network also solve the nonlinear problem. SVM also solve the nonlinear problem. But advantage is that computation complexity is less. It requires less number of samples, and that's why in some of the cases SVM is really champion compared to the other classifier and so on. So conclusion is that this empirically we can achieve the excellent result in high dimensional data with a very few samples. The internal capacity control to avoid overfitting is possible, means overfitting problem can be solved. Then can learn both simple linear and very complex nonlinear functions by using kernel trick, and this is robust to the outlier or noise by using short margin. You can do it. Convex QP optimization problems can be also solved, and solution is defined by small subject of training or support vectors. Number of pre-parameters is bounded by the number of support vectors and not by the number of variables here. Do not require direct access to data. Work with only dot products of the data points. So here simple dot product is used and so on. So thank you very much. That's all from my side. So here in our lecture, what we have covered is that I talked about different types of classifiers. Then I talked about particularly this one, simple supervised learning approach, and in that KNN classifier. Okay. Then after that, unsupervised learning approach, there I talked about this one, Chemis algorithm by extending the minimum distance classifier. And then I talked about support vector machine. So in support vector machine, there are three things. One is basically maximizing the this one problem, maximizing the basically margin. Second thing is that okay, you can solve the nonlinear problem by using Gaussian trick. And then third important thing in this one is that this will work very well even if number of samples are less. So if your problem is having only less samples, then instead of going for neural network approach, you can go with the simple SVM classifier and so on. So that's all from my side. Thank you very much.
Thank you so much, sir. So with your permission, can I ask the participants that the forum is open for the question answer session?
Yeah, please.
Okay, sir. So all the participants, I just want to tell you the forum is open for the question answer session. So if you are having any queries, please raise your hand, or you can just unmute your mic and you can ask the questions.
Thank you, Patil sir, for your comment.
Yes, is there any questions for the participants, please?
Thank you, Yogita. Thank you, Vinaya, Vijaya. Yeah, I expect that at least you might have got overview because see that. So these are the big subjects. So you really need to go into deep insight of that one. Okay. But at least you might have got idea where we can use what. At least that one. That is what I'm expecting.
Yes. So I just
Thank you,
want to
Ganesh.
request you that a few of the candidates, participants, they were asking for your email ID and phone number. Will it be okay if you will share your first?
Yeah, surely, surely. I'll share. Thank you, Mrinalini, as well as Ashwini. So I'm sharing my this one email address mpkokre @sggs.ac.in. So this is my email address, and my phone number is 9421474393, and another one is 9518595365. So these are my. Thank you, Trupti. So these are my numbers. So if you have any doubt, you can ask at any time. It's not like that you can ask only this time. Okay. So yeah,
Thank you
and
so much.
also visit Nanded. Nanded is also a good place. We have very good center of excellence here.
Yes, sure, sir.
We have established.
Yes, sir. So, Dheke sir, shall I proceed, sir? Okay.
Yes, ma'am.
So, okay, sir. I would like to express my heartfelt thanks to Dr. Kokre sir for giving focus on so many aspects such as types of the classifiers in machine learning, basics of machine learning, and the examples that you have given considering the Amitabh Bachchan and Amir Khan. Those are truly outstanding, sir. Also, we understood how systematically and stepwise to solve the numericals in k-mean clustering and in various topics too. Generalization, hyperplane, and separating hyperplanes. These few topics are also found to be very fruitful, sir. And the mathematics behind super vector machine is also very tricky, but we understood it in a very well mannered. Thank you so much once again, sir, for sharing your valuable knowledge with us. I also want to extend my thanks to our principal and convener of this FDP, Dr. D.S. Burmane, sir, HOD of E&TC and co-convener of this event, Dr. S.B. Dhonde, sir, coordinator of this event, Mr. S.B. Dekar, sir, and Mr. V.B. Gavai, sir, and to all dear participants for their patience listening. I request all past participants to take out some time and give your valuable feedback for this session. The link is already provided in the chat box. Thank you everyone once again and have a great day ahead.
Thank you. So
Thank you so much.
I wish all the best to all participants and congratulate you people for organizing this session. Okay. So with your permission, can I take a leave now?
Yes, sure, sir. Thank you so much, sir. Thank you.
Thank you. Thank you very much.
Thank you, sir. Thank you, sir. Thank you.